Ms. Shifa, would you like to start?
Sure. So I would just like to welcome everyone to the third workshop in our series. Today's workshop is going to be hosted by Professor Shahid Hassan and moderated by Mr. Hasnan Zafar Baloch. The workshop is entitled Psychometrics as Reliability and Validity of Assessment. I just wanted to welcome everyone on behalf of Sadiq International University and Imamia Medics International. So please, if I can invite Mr. Hasnan to begin, and it will be a very exciting session.
Thanks, Shifa, for organizing and working very hard behind the scenes. And I would like to welcome all participants. So we have roughly 40 participants already joined in. Prof. Shahid, what's your opinion? Shall we start our polls and survey, or
I think we wait after this.
Okay, so sure. So floor is yours. Just to remind all our participants, please mute yourself. And if you have any burning question or any thoughts, do use chat, and I will filter all your questions and your concern, and later on in the session, I will ask Prof. Shahid to cover that. And let's get ready and enjoy. Yes, Prof. Shahid, all yours.
Thank you, Hasnan. Thank you, Shifa. And thank you, Prof. Zadi, for really motivating us on this forum and making us really share our knowledge and learn from each other. That has always been your objective, and we are with you to assist you in your this objective, which is dissemination of knowledge and particularly skills. That we see that these days a lot of webinars are going on, and particularly in all areas that we really need, particularly on COVID challenges and COVID pandemic area. But what is really needed is the hands-on skills that one can learn and practice it in its institution. So this topic, which is psychometric as reliability and validity of assessment, the first part I'm going to begin with which would be about reliability. So the post-assessment evaluation, this is very important and sensitive area, because if you really want to have a continuing quality improvement in assessment, you need to have a consistently performing your evaluation of your assessment. This is important. But sometimes we do this evaluation as part of accreditation need or higher education need. But what is now needed, and I will impart on you, and I will make your interest in knowing how exactly would you know that your assessment has been really as minimized towards error as possible. Though we know that the observed score is true scores plus the error, and we can never know the true scores actually, but there must be an effort on our part to reduce the error as much as we can. So standard error of measurement, which is hardly practiced, would be the focus of my topic at the end. I'll take you through how errors can be determined in written tests, which is MCQ and SCQ and all written tests and other written tests, and then standard error of estimate. So there's a different standard error of measurement and standard error of estimate, which is particularly for the OSCE, which is practiced with a standard setting, right? So moving on towards reliability, here there is this part of the workshop has two learning outcomes. Describe the concepts of the reliability of assessment as a continuing quality improvement in your assessment practice, and that interpret the SPSS Excel output of a reliability statistical method. So these two, first part would be more through plenary that I'm doing now, and the second part, which we have exclusively kept enough time for that, so that everybody can use the fictitious data. Moderator will share with you those fictitious data I'll be doing, and you can follow through. And later on, I'll give you the solution part of it, which is also recorded, and then you can, when you do as an answer, you can refer back to those. Okay. So the psychometric basically in terms of assessment, usually this term is more used by psychologists, right, in their survey and all. But in assessment, when we use it, it is defined as sum of the utility of reliability, validity, practicality, and educational impact at the end to make assessment meaningful, right? Assessment is no more an assessment to award degrees or to sort of enable students to graduate, but assessment is now worked a lot on globally to make it more meaningful and assessment for learning. So to make it assessment for learning, utility, which is psychometric of assessment, basically within its fold, it takes reliability, validity on the top. So of course, practically and educational impact is the other, which are the industries associated with our medical education is looking at us. What kind of graduates, are they fit to practice graduate or not? And this fit to practice graduate will come up not by just teaching learning methods, but also looking at them, whether the learning outcome set for those teaching learning method has been achieved or not. So this is a burden on assessment now to answer that. Okay, so produce fit to practice graduate. So what is reliability? This is basically about consistency, dependability, and stability. So we talk of the consistency, which mostly we'll be talking about, is about the, don't mix it up. So that when I'll try clear the concepts here. So consistency is more about the inter-item consistency, how the items are consistent to make an assessment reliable. This is consistency, right? When it comes to dependability, it is the reliability which contributes to our validity. Remember, the validity needs reliability. A test cannot be valid without reliability. It's not the other way around, right? Not the other way around, that reliability needs validity, but validity needs reliability. So their test has to be reliable to be valid as well. So dependability, we'll talk more about that. And stability is in terms of time, in terms of administering you see, it's not necessary that you administer a question. You must have seen in OSCE that OSCE done in the morning hours and the same cycle repeated in the afternoon hours, the results of the same cohort of the students is different, right? So the time matters. How it matters, there are a lot of things to be talked about it. So stability is in terms of time, okay, period. So the classical test theory, which is something that more emphasis came up on reliability, is that an observed score, which we produce, the achievement score of the student, which we gave them at the end of the day in summative assessment, is the true score plus error. Now the error is never, actually, we never put our efforts to find out what those errors are. So a true score can never be determined. It's not possible, right? Unless somebody is still not possible. But what we can do is we can minimize the error. But to know the error is not an easy task. Generalizability coefficient probably can answer that. And then a standard error of measurement, which I'll touch at the end. Generalizability coefficient, probably we'll have to have a advanced course on that. Even there is an advanced course or standard setting at this topic, which we probably will see those who are attending these assessments, if they attend that level or an interest. I mean, we are not going to test them for what they have attained or not, but actually their interest, we can offer them some advanced courses on these topics, right? So the true score can never be determined, but what our effort should be to find out what is the error. And this error, remember, is not, we always blame students. We always say this, the error is on the part of the students. No, it's not necessarily on the part of the student. It can be on the part of the faculty, or an interaction between faculty and the students factor. So there could be many factors, but what our effort should be to minimize these errors, right? So to reduce the magnitude of the error by maximizing the true variance, right? If the variances are there, so the true variance should be maximized and minimizing the error variance, right? So we will do as we go along. I'll make it easier for you. So first of all, how do you interpret the reliability? In terms of consistency, different assessment tools are used, like the Cronbach alpha, split half, parallel form method, and on test, retest, iterator. In all, reliability interpretation goes 0.9 to 1 is supposed to be the excellent reliability, right? But it shouldn't be 1. It should approach 1, but never should be 1, because 1 means items are redundant. Okay, multicollinearity will be coming into question. So it shouldn't be exactly 1, but it should approach 1. So 0.9 onward is excellent. 0.8, 1 to 9, 0.9 is very good, and so on and so forth. But what is acceptable cutoff point is 0.7, right? So this 0.7 we should remember. Below that, we have to think of reviewing our assessment again. So the meaning of high and low reliability, what really it means to us, right? I'm trying to make it not to go into very scientific jargon terms and not terminology. I'm making it so that it carries your interest. So to us, reliability in assessment, how we look at it, high reliability is what? The question of a test tend to pull together, right? They go along together, they are consistent, and a sample of the question that is answered correctly are more likely to be answered other questions correctly as well, right? So this is what the reliability would be aiming at. The low reliability, the question tended to be unrelated to each other, right? So items or the question, if they are unrelated, for example, you see, you might have observed that when we set our questions, say 100 OBAs, usually either it goes by discipline, internal medicine will come, then family medicine, then gradually go on to minor subjects and all. And sometimes we start with the easier question earlier on and difficult later on, right? So this will also create problem. This shouldn't happen actually, starting with the easier question first. We think that we are helping students, but it works other way around, especially when it comes to reliability. I'll show you when I do this split half method, how it affects the reliability, okay? So the low reliability question tend to be unrelated to each other in terms of consistency. So a retest method, so now I'm taking on the types, right? There are multiple types, what I'm going to take, which is very practical. A retest method is exactly what we have been doing. If you have attended our other workshop on this webinar, on Al-Sadiq University webinar that we have been doing, we have been using pre-test, post-test. This time we have changed it to a small survey, because the topic is important, and we need to know your background, and that what exactly are you practicing and where are you, so we can take off in our discussion from that level. So actually the retest is exactly what we do. Is a pre-test, we administer the questionnaire or items in beginning, and then we do the intervention, which is a workshop, for example, and we do post-test, and we look at the items are the same, right? You can do it without having any intervention, or you can do it, but in workshop, usually there's an intervention, which is the workshop itself. And then we look at, we actually looking at the impact of the workshop, whether from the pre-test you have improved or not in your post-test, right? And we have seen the workshop we have worked on, workshop has shown its impact on you in terms of post-test. So the pre-test and post-test is a simple example is that. But again, the time constraint, the time factor, sometimes it shouldn't be too far away to look at the reliability coefficient Cronbach alpha. Too far away, for example, between the two phases of time, one may have come across some intervention or some additional reading on attending the workshop or skills and all. So this will not be the same. So this is something we have to keep in mind, that test pre-test, test retest is actually in terms of time period, and that time period, can you think of some, let's make it more practical. Can you think of some variables in your field that is unstable over time? What can be the best example? Say, I give you a clue, right? What is the best example to this? the COVID area, the COVID pandemic era, what really we face in assessment. Can anybody want to share that you found that the same variables were still not very reliable? Their reliability changed. Why it changed? Anybody can share the idea what happened?
Yeah, Prof, we got one mood, for example.
Uh-huh.
Mood of a student, I think, or I don't know, mood of, yeah.
Okay.
You can use chat to answer Prof Shah's questions.
Okay, and I'll keep moving so that we cover on time, because time is very important in this workshop. We have to do a lot of hands-on. So actually, you see, in a COVID pandemic, assessment was done, the same assessment. See, the same assessment tools which were administered to the students during COVID period, it was found that the students who were performing poorly before, they were performing better than the good students. Isn't it? We all noticed that. So actually, why this happened? This happened because the variables, the assessment that we have been doing with them in say like open book exam and all, actually we didn't bring our questions to that level where proctoring impact, because proctoring is invigilation is not there. The students is supposed to have free access to all the knowledge they can have. But the point was that we didn't change our assessment tool to counterbalance those, right? Counterbalancing is very important. We didn't counterbalance with moving our items to problem solving level, high order test of our high order thinking, right? Had we done that, probably proctoring, which is very expensive to really practice, and then in some schools, invigilator was put and asked to watch 10 students with all the time showing their mobile being placed there and switched on, and that was actually causing the heating up of the mobiles and all. And then some schools couldn't afford the tools which could actually offer proctoring online. So what happened? The simplest way to do away with this all was to actually bring our question to at problem solving level test, making it a high order test of high order thinking, where students cannot find answer easily through Google's and other support. Okay, so this is very important to think how the things has been changing from a certain area. The same test which is reliable in one environment is become unreliable in another environment. And the reasons we didn't explore, actually. We should explore the reason why. And the one reason I told you already, right? Now coming to the next is the parallel form method. So compares two equivalent tests. So we can administer, for example, we are doing OBA, there's 100 OBA, and that's a need also. When we do Cronbach alpha, actually, we need at least 2 sets of the score. So often the school will divide 100 OBAs into 50 and 50 OBAs, right? 50 at one time, 50 another time. So this is parallel form method, but you not necessarily that you divide your assessment items of the same construct into 2. You can use an item of the same tool, but you can use within the same construct, living within the same construct. For example, it is the written test of knowledge. You can administer, for example, OBA in the morning and modified essay question in the afternoon, but more appropriate will be OBA versus extended matching question, right? So if you use those at different at the same day, this is parallel form method, and then do a correlation and see how the student perform. So it is expected the students who perform better in OBA and when they were after a gap of 1 hour or a break or something of half an hour and all, and we administer extended matching question, their performance should have been the same. If not, then we have to look back to our assessment, not putting blame on a student. We have to look back. This is called parallel form method. Okay. So next is the internal consistency, which is the most practiced and the tools that is practiced is it is the intercorrelation among the items. So first thing, so inter-item correlation. So this is this can be evaluated through coefficient alpha, split half, and KR20. I'll be talking on all these three, but a good news is that KR20, don't get carried away with this. KR20 is nothing, but it is the same as coefficient alpha or Cronbach alpha. The only thing it is applied in items which is dichotomous answer. For example, OBA, yes or no, true, false, true or false, right? So those with dichotomous answer, there the Cronbach alpha becomes KR20. Even the SPSS do not offer any special method or tool for calculating KR20. KR20 is still calculated using the Cronbach alpha. The same when you drop down the methods, still it is in SPSS you don't find KR20, but the tool that we have to use again is coefficient. But only the data sheet that you develop from OBA, which is dichotomous, versus SAQ, where you have a score, a subjective score and all. So that makes it, that's the only difference. Split half, of course, I'll talk a little more in detail. And why? Because this is a constraint that often we get scores from our examination unit for evaluation. For example, OBA, all 100 students have taken exam, 100 items is administered, and we get a score of 100 students, one set of score. Remember, Cronbach alpha or coefficient alpha cannot be done with one set of score. We need two sets of the score, right? There, the split half, people ignore split half, but sometimes split half become a necessity for you. Even if you're doing for in our center, my center in IMU, we have an online assessment. A lot of metrics is generated. We only have to interpret. We don't have to perform. We have to interpret only the metrics, the results, right? But we found that such an expensive online assessment system is taken. It doesn't generate the Cronbach alpha. And when we tried to calculate, we couldn't do it because the score was provided to us as one set of score. So then we asked to give us the entire 100 item score so that we can do split half, okay? Because remember, the coefficient alpha can be performed between 2 to 5 items. If you have a big list of items, so when you ask, they have submitted a score of the OBA as a one set, which doesn't fulfill the criteria of doing the alpha or the Cronbach alpha or the coefficient reliability, then we need to ask them to give us the detailed score of each item. But detail of each item, you cannot bring into the Cronbach alpha box 100 of items together. That looks very messy. So what we do is we will do the split half. We will divide them into 2 halves and create 2 sets of the score. This is all about the split half method. So this divides the scores into 2. So, but the problem is that in Cronbach alpha, the whole length of the items, the whole length of the test is actually evaluated or tested. Here, half length of the test will be evaluated. So how can we overcome this? It's possible. Pearson's correlation has offered a solution to it. And this solution is that we, instead of going into dividing it into upper half and lower half, we divide into, and I will do with an example with you that how it really produces different results. So what we do is we will take odds, let's say 100 items, 100 questions submitted to us from the examination unit, the results. So 1, 3, 5, 7, 9, 11, all odds number will be made one set and all even number will be made another sets, right? So this is also possible in this PSS. I'll do such an easy, if you can do it in 1 minute. It looks very messy. How will you do that? But will not take more than a minute. I'll show you with example here, right? So odd and even items divided into 2 halves so the problems, that is the half length of the item will be tested for the reliability, will be overcome with the Pearson, the compensation come from that, as well as making it odd and even numbers 2 halves, okay? So now KR20, it is the estimate of the internal consistency. Cronbach alpha is more appropriate for nominal interval data, right? But when it comes to dichotomous, that is yes or no, true or false, then you just change the name, just call it KR20, but it still is the Cronbach alpha. Okay, so in Cronbach alpha is achieved as a the KR20 is achieved as an alpha if the data is nominal or dichotomous. Process is the same. We'll do it in a practical session in the second half. So in SPSS, KR20 is done similar way as done for alpha, right? And even there's no mention of the KR20 as a statistical tool in the SPSS. So the formula is very cumbersome, is difficult, but we will do it using the SPSS. Okay, it ranges from 0 to +1, right? And it was introduced much before the Cronbach alpha in 1937, right? And the Cronbach alpha was introduced later. Okay, so KR20, the methods would be how we do it. The alpha value of KR20 can be calculated in Excel by two different methods. In SPSS, we use Cronbach alpha, we use alpha, but in Excel, you can also do it, right? So when you're doing it in Excel, it is reliability index alpha quality method 1, where we will use the ANOVA method, right? With ANOVA, we get 2 scores. I'll show you all this practically. So we have 2 scores, the MS error and MS rows, right? So this will be this error and rows values will be used to calculate 1 minus MS error divided by MS rows, which will be produced as we do ANOVA, right? In data analysis, we do ANOVA and we get this table. So only thing we have to use this formula to apply it to it. The other way would be to go and do the first the correlation, Pearson's correlation, which will generate a table. Then we have to calculate the inter-item correlation average, which is not very difficult to do as well. And then we use this formula here, right? Where is my cursor? Oh, okay. We use this formula here, right? K is the number of item and R would be the inter-item correlation average, which we will calculate in Excel. So these are the 2 methods available apart from SPSS, which is very simple to do actually. So if you look at here, here you see this the MS here is a row. Top is the row and below is the bottom. There is the error. So these 2, which will be generated from our doing with in data analysis as ANOVA method, and then what we do is simply 1 minus, just plug in these numbers, right? The 0.322 and then first 0.174, which is here, right? In row, right? MS row and MS error and MS row. Error is your will go there, right? You divide it row with the error with the error with the rows, and you get this. Of course, you have to have 1 minus this. Okay, so there you get your this reliability coefficient using this. Okay. The other way is you go and do the correlation, Pearson's correlation. This table will be generated. Then you have to have the equal sign. You put equal sign average, then highlight all this, then put a comma, highlight all this, a comma, highlight all this, a comma until end. And then this will give you, you just enter, and this will give you the inter-item correlation average. This is used in calculating the Cronbach alpha. The other thing is only the number of items. So though formula looks very messy, very difficult to, but only 2 things we need. K is the number of item and R is the inter-item correlation, which we will calculate from the Pearson's correlation obtained through this table. Okay. Now the third is the coefficient alpha, which is mostly used actually. Modified formula from KR20 so that it can be applied to the measurements other than which is non-binary or non-dichotomous. Okay, deals with the continuous responses, evaluate the extent to which the different items on a term test measure the same ability or trait, If items do not measure the same characteristics, the test will not be internally consistent. This is what we are looking at in Cronbach alpha. Okay. So this will do in practical session, we'll do, these are the few steps. You will learn this very fast, no problem. Okay, so what we get from doing the Cronbach alpha, what we get item total correlation. So it's not only Cronbach alpha, we get some other things also. For example, Pearson's correlation coefficient as a special case, point by serials correlation. This is nothing, but if you remember in standard setting item analysis, we talked of item difficulty and item discrimination. So point by serial correlation is nothing but another way to know the discrimination, discriminatory abilities. So it's item ability to discriminate between good and poor. Remember, the assessment is all about discriminating between good performing students from the poor performing students, right? Keeping that in mind, problem by serial actually what it does, in simple words, a single item a student has performed, whatever score he has produced, is looked into overall score on that assessment tool. And we just do a correlation and we see how a student, so a students who have performed good on one item is supposed to correlate well with the overall, all other items in that test, right? This is point by serial correlation. Not difficult, right? So the concepts. So one item in how it correlates to the overall score of that assessment tool makes it point by serial, okay? -1 to +1. Then a corrected item to correlation. Corrected item correlation is between each item in a scale that excludes that item. So in remember in point by serial correlation or simple Pearson's correlation, the item's score is also included in overall score. But when you do corrected item correlation, the item score is minus the overall score. So this is corrected item correlation. But the most important thing is Cronbach alpha if the item is deleted. So what happens? We have a Cronbach alpha calculated. We look at all items and it will be a table provided. Here, this is an example. Luckily, I put this here. So say, for example, you have calculated the Cronbach alpha, which is 0.365 here, right? Now, if item deleted, so for example, OSCE 1, if I delete, what happens to the Cronbach alpha? Cronbach alpha we have calculated is 0.365. If I delete the item, it goes down, meaning this item is working well, okay? So here, all items, but here, if you look at here, this item, item 4, actually you have to see whether when item is removed, the Cronbach alpha goes up or down, right? If it goes up, then that item, if it's removing the item, the Cronbach alpha goes up, that means that item was not doing well, okay? So you have to look at it. If item deleted, how the Cronbach alpha is responding. 0.365, what happened to it? Here you see 0.086. It is when the item 4 is removed, the Cronbach alpha terribly fall, right? This means this item is very important. If you remove, so the most of the burden of the Cronbach alpha is by this OSCE station 4, right? So that's what is item deleted. Here the corrected item total correlation. Here the total score which minus the OSCE 1 score and OSCE 2 score and all, right? We look at that. Okay, so this is how we look at it. So item corrected correlation, and then this is the correlation which you all are familiar with. How the each item 1 versus item 1 of course will be 100%. But item 1 versus OSCE 1 versus OSCE 2, the correlation is there, but it's poor, right? Correlation is minus, even bad, right? Here the correlation is little better, okay? So moving on, actually, time constraint, right? I have receiving warning from the moderator. So point by serial, I have described to you. This needs another workshop actually in detail to make you learn how we do it. So what you have to remember is typically -1 to +1, right? 0.25 is something which can, when you achieve any item achieving 0.25 point by serial correlation coefficient, this item is working well. But the school can pick up. In IMU, we have pick up 0.25, but you can keep it 0.3 also or less also, right? Here, for example, in the OS generated metrics, you see the point by serial is already calculated here. So you, if you look at all the item in our guidelines that we have set 0.25, these two items are not fulfilling the criteria. 0.14 is less than 0.25, 0.21 is less than 0.25. So we have to look back into these two items. The others are okay. Okay, this is machine generated, only we have to interpret. Okay, so actually what we look at the point by serial, we have to calculate the average overall total score who passed the exam, and the average overall total score who failed the exam, then proportion of those who pass and proportion those fail, and then you apply this formula over there with the standard deviation and square root and all, and you calculate the point by serial. But more important is how do you interpret it. Okay, so this is for example this is the formula, and we have just plugged in from something which I have got from the machine generated metrics, right? From there I found this all MP and MQ and P and Q, and just plugged in here, and I got this point by serial. This is the formula. Okay, OSCE measurements of the clinical competence, root mean square error. Why I'm introducing this? Remember, Cronbach alpha, if you simply increase the number of items, say if you are doing 10 OSCE station, you make it 20, suddenly your Cronbach alpha will go up, right? Even number of students taking the exam will have impact on the Cronbach alpha, right? So this is not very realistic. The other aspect of it is that in what you call written exam, where the construct is the same, right? You're talking of the medicine question and surgery question, they are same construct. So the dimensionality issue is not there. In OSCE, you remember, students are moving from surgery to medicine to family medicine, ONG, ENT. There are diversified areas of tests that we ask the students to undertake, and that process might raise the dimensionality issue. And remember, the consistency of items. So their OSCE stations are by a very practice or eyeball rolling. You may understand that one station is not the same as the other. Emergency medicine, for example, versus another. So they are not the same. Dimensionality issue will come. So root mean square error, I'll be introducing this in the practical session. How do you do it is more realistic than to do Cronbach alpha in OSCE. Okay, we do standard setting. I'll not do. We have the standard setting done with the borderline group method, where all the borderline students score is taken and made an average, or borderline regression method, where the computer will come in and calculate for us. This regression equation is given. Based on the regression equation finding, we calculate the cutoff point. Okay, so borderline regression method is more better, more reliable than the group method. That we'll talk later. Is all about root mean square error. So OSCE reliability should it be alpha or else? I have given you food for thought. You have to think on your own way, and then you will realize root mean square is much more better. So I end here and over to moderator if there is question, but more than that, we would like to have survey first. So over to you, Hasnan.
Sure, Prof. Thank you. Okay, I'm sharing the link in the chat. So what I need you to take out your smartphones, or you could use a browser. And
should I unshare this?
Yes, Prof. Can.
Okay. Okay.
Okay, thanks. So let me share my screen.
Okay.
So what you need to do, you just need to key in pollev.com/IMU poll. And what I need you to click on the country from where you are logging in to this session. Okay, that's cool. We got some from Pakistan, from Iraq. Yes, if I'm not mistaken, from Malaysia, maybe. Yes.
They can click the right place.
Yeah. Yes. So we got
If you
from
would,
Indonesia also a few.
if you
Iraq
please
got a
browse it.
lot. Yeah. That's good. Well, maybe I can give you 20 seconds more, and you can click from
So they
where
are
you're
from
looking.
different region, right?
Yeah.
Can you quickly go? What are the region so far you picked up?
Yeah,
From the
we
board?
got on the map, we got like 2 from Pakistan, if I'm not mistaken, then several from Iraq, then we got from Malaysia and Indonesia, that region we got few. Okay, that's good. So let's move on to next question of the survey. Yeah.
You can choose more than one.
Yeah.
As you start answering, I will get the response
Yeah,
here.
I just looking at how many already responded. So we got 14, 15, 16 responded already. So let me show you the responses.
Okay,
So if,
that's good. Okay. So multiple true false and OBA are on the top. The OBA gets edge over multiple true false, and extended matching question also getting on the increase. Modified essay is 7%, a structured essay question is 11%, and a short answer is 14%. So all in all, we see that most of you are doing OBA, extended matching question, and multiple true false. Besides, of course, SAQ is also there, 14 and 13% is SAQ as well. So as the other would increase, the OBA and this would decrease. So it is a percentage distribution. So I can see that still OBA is taking an edge over all others, right? Extended matching question is also keeping its strength there. But what we are losing on is multiple true false, which is so true, you know. As we moved on to higher order thinking tests, we are thinking of OBA and extended matching question. So most of the institution are getting away with the multiple true false. So that's a good, we get what practically, and this is what we wanted to know as on SIV, this platform. The Prof. Zadi would also be interested in knowing how we are. So the next question is OBA in your institution. So do you practice OBA in your institution? So far the response is yes, no there's no no. That's why we are getting 100%. If we get any no, then this percentage will divide among the two, yes and no.
yeah, Prof, we only responses. So
okay.
Okay, so we'll move next.
Okay, Mook. So the OBA is 100%. Okay. So the long case is still used, and I'm such a strong proponent of long case, provided it is done properly. Because to achieve the validity and reliability, you need to have at least 8 long cases, which in summative assessment is not possible, but there are ways to do it. In Pakistan, I remember, I really salute my teachers who introduced long cases in every posting, in every exam at discipline level. So long cases were done. So long cases are still used, short cases are still used, oral is there, but what is taking edge over all these is OSCE. OSCE is getting popular, right? And rightly so, because in OSCE we can we can attain the reliability and validity more easily, because instead of one long case, we can have 10 or 15 or 20 stations, subject area, the the representation of the what has been taught and what has been assessed is over there. So it's 38%, but still I'm so happy to see those who are still using the long cases. And a clinician, Prof. Zadi will bear me out also. He will also will be a strong proponent of having a long case, which is a real test of a student assessment, performance assessment, right? So this should not be given away, this long cases. We should revisit long case, how we can practically make it, logistically make it possible, maybe not in summative assessment, but as an formative assessment during the posting, we can do long cases at each discipline, and perhaps we can use those long cases formative assessment at different point of time we can use for decision making in summative, as in a summative assessment also is possible. So there are ways to really revisit those assessment tools which were really the test of competence, which we have been trained through as well. Okay, so do you practice OSCE in your institution? So the response is, Hassan, can I have the?
Yeah, we're just waiting for a few to respond.
Okay, okay.
Then I will show responses. Yeah, 100%.
Okay, 100%. So most of you are using the OSCE, right? 100% like OBA. So what we get here is that OBA and OSCE are used by almost all the institutions. That's a good news. Okay, so now moving on to standard setting. This is amazing. Standard setting 100%. Now it gets 50-50, right? So as the no is responded, so this is going, and this is a real poll. Thank you, Hasnan.
Yeah.
So this is a real poll. Yeah, so 75% is using standard setting, and as more responses come, 80% are using, that's a good news, okay? We can move on. This is what we wanted, actually. Borderline group method or regression method. I'm expecting that you should use borderline regression method, 100%. No, it's 40 versus 60, right? Not bad. To begin with borderline regression method, one can switch over to borderline regression method as the skills and technology is acquired. So it's good. 33 versus 67%.
Sorry.
Okay.
Yeah.
I think that was the last question.
Yeah.
Oh, now reliability. Yeah. So what reliability tools are you using? Cronbach Alpha, I'm sure everybody would have been using. But if others are, oh, interesting. 80-20% still, yeah. This is very practical, a split half, where the Cronbach Alpha, for reasons that I told you, if the examination unit gives you one set of a score of any assessment tool like OBA, you cannot do. You have to have two sets. So if 100 OBA, either administer it 50 in the first hour and 50 in the next hour, and then compile the two sets of the score. If not, then you have no choice than to move over to split half. So that might have been the reason in some of the school that is still use 15%. I'm not surprised. Okay. So parallel form method, yeah, this is a good idea because here you don't have to do an effort. We have modified essay question, we have OBA, we have multiple true false. Like in criterion validity, we can also have a parallel form method. We can always have a correlation, and we should expect a good correlation if the construct is the same. Mind you, if the construct is the same, you cannot do parallel form method with OSCE score from the OBA score. Okay. So intra-class correlation. Okay, Hassan, can I see the intra-class correlation? Is possible to move back? Yeah. Intra-class correlation, yeah. So this is inter-rater reliability. 6% is still using it. Root mean square error 6%. Wonderful, wonderful. It's amazing, right? This is what, yeah. So we will have a good discussion later. Okay, next. So content validity versus construct validity. How do you ensure and do you really practice it? So content, I mean, everybody must have been using, whoever is using the blueprint, right? And the best time to do the content validity, because the content validity by experts is a very expensive logistically method, right? So we can't do that always. So what we do is a very good blueprint, and during the vetting session, the members in the vetting session ensure looking at the blueprint that the content has been validity has been achieved. Construct validity, okay. So you do look at that, and it's not difficult, right? We will tell you in the next half of the workshop. Concurrent validity is something where you have a criteria right? For example, if you think OBA is the very valid and reliable instrument and you're doing extended matching question, just do a correlation of that. So comparing one assessment tool with a gold standard is just the concurrent validity. So you have a criteria. It falls under criterion validity. Criterion validity is two, predictive and concurrent, right? So we see none have been practicing is still 7%, which is a very small number. But after this workshop, I'm sure they will bring in this message to their institution and will practice it. Okay, Hasnan, you are moving fast and I'm doing commentary like I'm doing a cricket match or football match like.
Yeah.
Okay. What is this? Standard error of measurement. This is interesting. 50%, 25, 70%. Yes. Okay. Okay. This will be interesting. Those who are using, please be a little vocal during the interactive session. I would like to share your experience. Those who are using a standard error of measurement, are you using it just to know the errors, or are you adjusting this error in your announcement of the result or not? That will be my question to you. So please do share your experience. This is very interesting and we will learn from your experience. Okay. So no is 25%, yes 42%, standard error, and not sure 33%. So it's still 42% are using it. So our question will be, if you're using it, really looking at those errors, are you adjusting those errors in your result before it is announced or not? That will be my question to you later. Okay. So please share that. Very
Yes,
good.
Prof. That's all.
Okay.
From my side, so I will stop sharing the screen. So over to you. And I would like to thank all participants for very active, contribution.
Hassan, can we have some interaction, because
Yeah. Okay.
we need to know, yeah, because my audience is quiet, so I don't enjoy that. So can we have some sharing of experience or comments or question? Do you want, or you do want me to move to next talk?
Sure, we can pick few. I mean, they said Dr. Amir Ahmed's current trend is to increase the number of OSCE stations.
Yeah,
so
that's right.
What do you think? Okay.
Yeah, current trend is to increase the OSCE station, because increasing the OSCE station simply you are covering the content more precisely. What you are teaching, you are covering them, but the point is it shouldn't you shouldn't compromise on the quality, because OSCE reliability, validity goes with how do you logistically manage it. Is institution have the adequate funds, faculty is trained, especially examiners that you involve from the Ministry of Health side, who have been teaching in your students in the hospital, but they're not actually involved in examination. They must be trained how to handle OSCE. So these all logistics has to be kept in mind. So increasing number definitely will value in terms of validity and reliability.
Yeah,
Other
sure.
question? Yeah.
How you could comment on that? How much validity of assessment matters?
How much validity? Okay. Validity, it will go with the type, content validity, construct validity. So the content validity is that we should actually cover over 80% what we have been teaching, right? It should be, and it should be a representative of the entire the implementation of the curriculum, or the teaching learning experiences that the students have undergone must be tested. So over 80% should be covered in content. Construct validity, the correlation should be more than 0.3. So more than 0.3, 0.5 is actually acceptable, but I have seen my experience is that often that correlation we do not achieve. So I assume that statistically anything correlation, PSS correlation beyond 0.3 is considered good, right? For predictive validity and for the concurrent validity, the correlation coefficients more than 0.3 should be okay. But if you achieve 0.5, you are very stringent in your calculation, then 0.5 is better, right?
Yeah. Another question is, what is the minimum number of OSCE stations in terms of validity and reliability?
Okay, this has not been remembered. People have been, institution have been taking off with less number, say 5. But when you have a small number, then do not marry to one assessment tool. It shouldn't be the OSCE with 5-station OSCE. It doesn't really mean anything, right? So if you are doing OSCE 5-station to kick off, then you have to have your long and short cases along the line. That is a good thing. Marry to multiple tools than to relying on one tool, which is sort of, if a small number, I would say doing half-heartedly, right? So minimum number should be 10 stations. So more the number. So people have thought 26 OSCE stations actually achieve the expected reliability and all, but 20. But in my experience, I would say anything over 10, between 10 and 20 would be okay.
Yeah, I mean, does validity is measurable item? Dr. Nazar had that.
Yes. Validity is measurable item. As we go in next talk, we will talk on that. Is measurable?
Sure. Yeah. Great. Then KR20 is only for reliability of OBA. Is this correct?
Or multiple true false. Any item which has a dichotomous answer, yes or no, true or false, right? Anything that is dichotomous.
Yeah. How it differ from alpha?
It is the tool is the same. Assessment, the statistical tool or the method is the same, right? Statistical test is the same, but the worksheet that you develop from OBA, it has to be item has to be binary or dichotomous. Yes, so the worksheet is 0 and 1. Either you achieve 0 or you all or none. You achieve 1 or full marks or 0 marks. So worksheet is like that, and if you do that, then it is KR20. And statistical test is the same as alpha in SPSS. What we will do practically, we'll show you in next half of the workshop.
That's all, Prof. Shahid, now.
Okay. Thank you very much. So that makes me little having fun as well, listening to the participants, especially, you know, we are used to face-to-face. Their question comes and we feel related. I do not enjoy doing workshop without questions. So questions make me learn as well, keep me updated as well. So thank you for your question. Those are very interesting questions. So moving on to the now sharing. I'll share the screen.
Okay.
This one I have to bring down and talk to. No, that one, this one we have done already. So I just close it. Oh yeah, this one. In the background. Can you see my screen?
Yes, Prof, we can see, but you need to show it in a full screen.
Yeah, I'm trying. I cannot press. Why?
Yeah, on the right side.
Yeah, but I am trying to press it, but it doesn't work. So
okay, make it first full screen. Yeah.
Yeah, can you make it full screen? I can give you control. You ask control, I'll give you.
No, I could not see here the option. You can try yourself. Try and make it full screen first. The next option, right side. Yeah.
Yeah. No, the slide is not moving as well. Is not moving as well. Okay, just a minute. I'll stop sharing and then. This is stuck here. Even I cannot minimize. Okay.
Okay, now we can.
Yeah, I'll go and let me have it share. Yeah. Is it okay?
No. Okay. No, perfect.
Okay, so we move on to the next topic, which is validity, right? So what we must know to interpret the result. So moving along, and then the two learning outcome for this, describe the concepts of the validity, of assessment as a continuing quality improvement of your assessment, and then interpret the SPSS and Excel output validity statistical data. Okay. So what is validity? Extent to which a test measure what it is supposed to measure. So you do a test with an intent that you are going to say, for example, you're doing OSCE. Your intent is to actually assess the students on their clinical performance. So that is the intent. And if you achieve that, but when you do the analysis and you see, for example, there somebody asked this question, is it measurable? It is measurable. For example, you do the construct validity of OSCE versus OBA. And what if you get, there is a very good correlation between OSCE and OBA. They are two different constructs. They should not correlate. So here, the two validity measures is convergent validity and discriminant validity. So in convergent validity, it is expected because we have a theoretical approach versus what we get on operationalization, right? So the theory says that the OSCE and OBA are the two different constructs. What is about the test of knowledge and other is about test of performance. But when we do the correlation coefficient and we get that they both are very highly correlated. So where is wrong somewhere, right? So we have to figure it out. So there is less chances that your OBA would be designed on the line of an OSCE, but there are chances where your OSCE is designed on the line of an OBA. So maybe your exhibit that you're using, you may not be using the simulated patient, or you may not, or the real patients. And the exhibits that sometimes you use, actually you have an exhibit, you have a scenario, but your questions doesn't relate to that. A student or someone can answer the question without looking at the exhibit or the scenario. So that be the case, then you will find OSCE developed as a test of knowledge. And there, often you would do it and you will find that your OBA and modified essay may not be as much correlating. I have found it many centers that I have been working with without naming. So the convergent validity was found good in OSCE and OBA or multiple true false, but not in modified essay and OBA, meaning that the questions developed were sort of a little confusion. What are we testing? Okay, so validity, relevancy. No test is universally valid at all times to all users, right? May not, as I gave you the example of the COVID pandemic, where when we went on to do it open book exam, we found it, the same questions were not doing well. The poorly, for my daughter is in a school in Pakistan. She runs a special section in one of the school in Pakistan, and she called me and she said, Papa, I did a test during COVID and the result has to be sent for the O level to London. And then she was worried because she saw the poorly performing students all the time in the school have done very well during COVID pandemic. So she asked me what to do. I can't send this result because this is not a realistic result to be sent to O level in London, because my good students, good performing students will be sort of, the situation will be embarrassing for them. So I told her, don't send the result, instead develop another questionnaire and develop it as problem solving level. Take it to higher level whereby the Googles may not, and then she did it and she very happily called me back and she said that the result has been achieved the way she was expecting. So, you know, sometimes this is very often because who is doing on their behalf? Proctoring is not very good, and at school level, you can imagine they cannot afford to have a good e-learning tools to do the invigilation kind of thing and all. But simply designing or structuring the question at the problem solving level, good students perform well and poor went back to their original status. So this is very important, right? So the form from time to time, culture to culture, the validity will change. Okay, from pandemic era to normal era that we found it tremendously changed. achievement score. Okay, so Trinitarian model, which is multiple aspects, but they mean together, they mean one thing. This is what called Trinitarian model. So they are different names, they are different aspects, but they all are leading towards validity. So we have content validity, we have construct validity. I'm putting all important now. I have done away with the face validity, external, internal, and all that doesn't make much practical importance. Content, construct, and criterion validity, which is predictive. And if you learn this, I think it's more than enough. Okay. So looking at the content validity, degree to which the measure covers the range of the meanings included within a concept. So theoretical concept that I gave you an example that OSCE should not correlate well with the OBA on operationalization. When you get it's correlating, that you have to look back into your OSCE. The test blueprint is needed. You should not practice, or you cannot achieve content validity without that. The blueprint is very important. Say, for example, you invite me as an external examiner. First thing I will ask you, can I have the blueprint of the exam? And often the institutions feel that the blueprint is something which should be hidden from the students. One institution I was working, the dean asked me to develop the blueprint as they developed the medical education unit, taking me in. And then I say, whom are you going to use it for? And they say, accept students. So I point blank, I told dean, I'm not going to develop the blueprint for you. She said, why? I said, because you are not giving it. The first stakeholder to have an access to the blueprint is the students. Remember, this message I'm giving across, please adhere to it. Student must have, it's not the blueprint of exam question, it is blueprint of the exam. For example, the waiting, right? So the longer the waiting, internal medicine, how much question will it come from there versus ENT or ophthalmology? What would be the difficulty of items? So you will be having some, the C1, C2 question until C4, C5, and 6. The student must know it, right? In terms of waiting. The assessment tools, what assessment tool? So these are the blueprint. So blueprint and how the content validity will be ensured. That, for example, if you are looking at the history taking, examination, well, investigation skills, management skills, and all should be equally represented in blueprint. For example, in MQA, Malaysian Quality Authority, or the framework, undergraduate, we are supposed to achieve C1 to C4, right? If we achieve 5 and 6, it is up to us. But all institutions must have question to attend C1 cognitive level, which is factual knowledge, to comprehension, to application and analysis, right? Synthesis and evaluation is up to the institution. If they want to bring up the test of their higher order thinking into practice, it is up to them. This is one. The other thing is, this is about the cognitive. The other point I've offhand, I just is important also. Blueprint is important in a way where a student must have an access to it, and then examiner, when they come, they should have a blueprint to follow through to see the content has been achieved or not, content validity has been achieved or not. Okay, so blueprint will tell that, and that you can do it as the time of vetting session also. I give a lot of importance to the vetting session. In vetting session, actually, you can ensure also this content validity, because to do it, inviting the experts, you see how cumbersome it will be. Other way is to invite the experts and give them the whole set of the assessment you have prepared for the exam. For example, taking into expert, often the people invite 1 or 2 external and give the whole set and then ask them to do the content validity is exercise in futile. You shouldn't do that, right? Because there are certain assumptions that we must meet with. Expert panel, if inducted, should be in reasonable number. Okay, and I'll do in next slide. Content validity ratio is about each rater. Is the skill knowledge measured by this item? Item is essential, useful, not essential, not useful. So they should go to that extent, right, to give the content validity. For example, you have been teaching them something and you are asking something which is not covered in teaching. and which is not important as well in their practice. So the person doing content validity should look into that, and they should, then it is in a score. Somebody who asked this question, is it measurable? Yes, it is measurable. You give a score like you do it in a standard setting. So multiple examiner, for example, if you have 5 examiner, minimum should be 5 experts. If 5, then CVI, content validity index, should be 1, right? Meaning that all 5 must agree to the same conclusion, same marks. For example, I'm giving marks. Somebody give say 80% or 0.8 or 0.9, but they should overall will have a consensus. But if you're using 6 experts, then even if we achieve 0.83, which is measurable, right? So it is still okay. If you're using 9 experts, then 2 could disagree, it would still be okay. But most of the time we practice is B, okay? So we must achieve 0.83 consensus on the part on content validity. Now, I think I have answered, it is measurable with the experts involved. Evaluation of assessment, of course, I'm going through this, just this cartoon, so that you can see that when it is a very small sample, that may not be a good idea, right? Not even for the students, not for the teacher as well, because teachers may have, they have been teaching all along the years, and the test is very small, is not a representative sample. So you should have a reasonable one, right? Now coming to the construct validity, underline unobservable traits, right? A construct is determined by referring to the theoretical construct, as I said. So the written assessment tool, MEQ or OBA, they are of the same construct. This is theory. And OSCE and OBA are of the different construct. This is a theory. On operationalization, we take the score of the OBA, we take the score of the OSCE, simple enter, develop the data sheet on Excel or SPSS, and do a correlation. If your correlation is 0.3 above, is it still okay, acceptable, but literature says it should be 0.5 and above. So if you get a correlation, Pearson's correlation of the 2 scores, then it is okay. But this construct validity will have 2 components. Convergent validity, where the scores are convergent. You see here, the literature is keeping it so high, 0.7, which I will not say, because you can hardly achieve 0.7 in correlation between, even if it's the same construct, right? If say extended modified essay question or OBA or extended matching, they are from the theory, but you may not be able to achieve. So anything statistically in correlation, 0.3 onward is considered acceptable, but 0.5 is quite good. 0.7 is hard to achieve, but if you achieve, is good enough. But what we look at it here, for example, the heuristic suicide ideation scale correlates. Here you see when they do this scatter plot, this is a good correlation. Here there is a negative correlation, right? So we have to see this convergent validity is seen through the Pearson's correlation score, which is measurable. Okay. Next is the discriminant validity. So OSCE and OBA, I'm taking picking up time and again the same example, so that once for all is very clear to your mind what the discriminant and convergent validity is. So if you're comparing the Pearson's correlation, you are running the 2 scores is from the examination unit. You develop the data sheet in SPSS. You run in 1 minute, so you get a correlation. If it is 0.5 and above, then it is the convergent validity, not discriminant. OSCE and OBA should have discriminant validity. They should have a poor Pearson's correlation. Okay, you get this point? So this is how, this is all measurable. Okay. Now, next is the, here, for example, self-esteem, measure positive effect, and then the artistic ability. You can see 1 versus 1. So item 1 versus item 1, of course, will be the 100%. So it is 1. But 1 versus 2, 0.90, it's convergent validity. 1 self-esteem versus measure of the artistic ability, 0.1 is discriminant validity, right? Discriminant, and it should be there. Do you think self-esteem has something to do, is important to do with the artistic ability? Probably the result is showing is not. Measure of the positive effect with self-esteem probably is correlated and should be correlated. So it is convergent. So this in this color and versus blue is discriminant at this. So this is measurable, and you should do it in constant and content validity with index. So give me a break. Just a sip of water. Okay, now coming to the factor analysis. The other way would be do a factor analysis, and this is very interesting. You do it in your OSCE. Say, for example, you have 10 station OSCE, and in a school, I was surprised when I did. They have 10 OSCE station, and then when I did the confirmatory factor analysis, they should fall when the item loadings comes. This is the process, right? It's not the forum to teach you this, but I'll give you the concept. But you can come and attend the advanced psychometric workshop, where we will make you learn how the confirmatory factor analysis becomes important. For example, you have 10 station OSCE, you do confirmatory factor analysis. They should ideally the loading should be in one column, but you will be surprised. I did it in 10 OSCE station in one institution, and they appeared in 5 different columns, meaning that they were of different domains, different. So they were not, the factor analysis were telling them that this test is not a true test of the clinical performance. They were a mix of something, right? So factor analysis will do that. Criterion validity, coming to that, how well does the test correspond with a particular criteria, which should be a gold standard, right? I gave you an example earlier on, or BA, for example, you consider is a gold standard. You have introduced extended matching question. Simple, do a correlation. 0.5 and above is good. If not, then this is not having a good criterion validity. In criterion validity, there are 2, concurrent and predictive. Concurrent is you compare the written test versus written test and see how it goes, right? So a written test that you compare with a newly inducted assessment tool should be done against a gold standard. And gold standard, usually OBA is a gold standard, multiple true false is a gold standard. If you're already doing that, on top, if you induct extended matching question or some other new tools, then you should do a correlation and see how does it correlates with those gold standards. Is concurrent, right? And the other is predictive validity. Predictive validity is down the lane. Your graduates, after 3 to 5 years graduation, you must try to look at it, and this is the need of the industry, right? You want to improve your curriculum delivery, your curriculum as such, teaching, learning strategies and all. You must do predictive validity. For example, our students, our industry is a hospital, right? Our students goes to hospitals, they perform there. Often the complaints come that they are not, the hospital faculty, consultants and staff is not happy their performance, right? So if they are not happy, you must have some evidence really, because often the complaints come, but what evidence they have? So in Malaysia, when I received a lot of these, I said, do you have any 2 years of husbandship? Do you have any assessment or evaluation of the student? They say they don't have. Only sign off, right? The supervisor will say it is he has achieved successfully, he has not achieved successfully. I say, can you introduce an assessment tool? So for example, if they introduce an evaluation or assessment, take that score, which is done 2 years after the graduation, and take the final year professional exam score, do a correlation and see simply how do they correlate. If they correlate well, that this student is performing well, is the predictive validity. This predictive validity is of your graduate performance, is not the tool's performance actually, is the graduate performance, right? So it is usually done 3 to 5 years after, but in our situation, we can do it 2 years after. Mostly housemanship is for 2 years. Okay, so this is about the predictive validity. Concurrent validity, I talked already, right? Factors affecting the validity would be test related factors, right? The criterion to which you compare your instrument may not be well enough established, right? I said you compare with the gold standard, right? You just simply cannot, because you're practicing it before. For example, SEQ, you want to do a concurrent validity SEQ versus OBA, it's not a good idea, because SEQ is very subjective, right? It's not a gold standard. So gold standard comes with the test should be very objective, right? The subjectivity issue and the other issue should not be there. So the gold standard should be a gold standard comparatively. Is never a gold standard, pure gold standard, but comparatively, right? So intervening events and the reliability issues are there. Okay, factor analysis, I told you, exploratory, where we do not have any idea. We go without idea and we do this factor analysis, and then actually factor analysis will tell us that our items are in one domain or different domain. The other would be confirmatory, that I said you can do with your OSCE. Okay, and this is I'm receiving some messages. I hope it's not me. Okay, so confirmatory is where you have already clustered. You have already clustered it, and then, for example, in OSCE, you want to see them as test of performance to be in the loading should appear in the same column, or it should be one dimension. But when you do confirmatory, you find it multi-dimensional compartment they are divided in. So then you have to think of that this is. So this, I'll not, hypothetical example would be a study of a school, for example, here, multiple schools involved, teacher effectiveness, facilities effectiveness, and management effectiveness. So there are some items for this, some items for this, for some items for this, right? But these items should, when you do factor analysis, they should fall. You think there's 3, 6, and 8 you have developed for management. Then if 10 doesn't appear in the teacher effectiveness, then because in your assumption, you feel it is, I have developed a question which is about management effectiveness, but the factor analysis will tell it, no, this is teacher effectiveness. So this is something amazing, and you should look into it. So assumptions is, I'll not go into detail here, right? So I'll skip. So you have to have cases KMO value, which is -1 to 1 should be on the upper side, right? And then you have a scree plot. I show you the scree plot here. This is a loading, right? You see the loading. Item 1, 2, and 3 are loaded up well, but others are not, right? So this will tell you that they belong to one construct, the others belong to other construct. Scree plot, this will be generated by the computer. So you see item 1, 2, and 3, they belong, and suddenly there's a turn from here. So they are two. This item, which was a test of, say, knowledge, is not test of knowledge or test of clinical performance. The item 1, station 1, 2, and 3 are clinical performance, but others are not. So this sudden change in direction, scree plot tells you that. Okay. So this is the yeah, that's all about the validity. Okay, I'm done at this point, and probably we can move on to practical skills. Over to you, Hasnan.
Yes, Prof. I think we should do a bit hands-on.
Okay.
Because I got a feedback that things are getting difficult and complex. So I think let them do something.
Okay.
And then.
Good idea. Okay.
Yeah.
Okay. So I share. First thing I will share is my. Hasnan, have you passed on the fictitious data to them?
I will do so.
Okay. So first I will take the easier one, which is I open my data in SPSS and do the Cronbach alpha first. Let this open. Taking time. Okay, this is the data. This data I have taken is a fictitious data to claim. Actually, we have manipulated it a little bit from real data, but not the whole entire set, because we want to keep the confidentiality as well. So the ID and all has been hidden, but here the data has been shared with you. You can use it also. So say we want to do is the Cronbach alpha. This is item 1 from say for example from OBA, right, 1 or 0, right? So either they get 1 or they get 0, dichotomous. So we should do KR20. So say I'm doing KR20, and now you see how I'm doing it. So analyze, right? From analyze you do go to scale, right? Then go to reliability, and there you just uh, uh, click here. You say you do not find KR20 here. So go back to alpha. KR20 would be taken care by alpha. The statistical method of the model is alpha. So you keep alpha here and then highlight all this, right, from here until the last one, which is how many? 10 items. Last one is outcome, right? The overall score. So, sorry. Item 1 until the shift. I have to press the shift. Item 10. Okay. I bring them to the item box. All 10 are brought to the item box. From here, this is I'm going KR20, but using alpha as a model, a statistical test. Now, statistics, what we have to look at, we are interested in items, we are interested in scale, we are interested in correlation, we are interested in means, right? And then we will click continue. Okay. So here we continue, and then we click OK. And what you get here, this is the output table. In output table, first of all, 30 items, all are valid, no missing data. Okay, Cronbach alpha is 0.449. Okay, so I get the Cronbach alpha 0.449, right? And then further down, we have the item statistics, which is telling you about the mean and the standard deviation of each item, which is sometimes important to look at which item has performed well than the other in terms of mean and standard deviation. But one word of caution is that never ever consider mean in isolation from standard deviation. Mean must be considered together with the standard deviation to make it meaningful. Then inter-item correlation, we had clicked, checked out that also. So it's inter-item correlation we can see. And ultimately what we see and we are interested is oh, I think I didn't press click the if item deleted, right? So what we do is I will minimize it and then I will go analyze again the scale. I think I didn't check out this. So the statistics, right? Yeah, scale if item deleted. I should have checked out this also, right? So I click here and I go again. Continue. Okay. Now I'll get that. Okay. This is important, right? So if you look at here, our Cronbach alpha is 0.449, right? So looking at here, corrected item correlation. So the item 1 correlates poorly the overall score, which doesn't include the item score in its fold, right? But this item correlates well too. So you can see here, and some is even negative. But what happens if item is deleted? For example, what is our Cronbach alpha here? We have seen here. Okay, this is 0.449. Now you see, if I remove the item, there is not much effect here. But if I remove this item too, then it suddenly falls to 0.304. This item is important, right? And all along as you go, even this item 9, when you remove, Cronbach alpha shoots up. So you can remove this item maybe in future, right? So the Cronbach alpha, if item deleted, this is very interesting finding. So it will tell you which item has performed well compared to the other, right? So this is how you do it, the Cronbach alpha in SPSS, right? So let me do the SPSS, because if I move on to Excel, opening and closing file will take long, but the same thing, you can do it in Excel also, right? So let me And then we are moving on to the next data, right? I will close. Do you want to proceed?
Okay, just want to inform participants I have shared a link, Google Drive folder. And can anyone confirm, are you able to download the fictitious data files shared in this folder? If yes, then Prof, you continue.
Okay.
Just use
So
chat
if you,
and
yeah, because I have shared all this data with you. I have been spending whole day on this, creating this data, right? And now next is a split half.
It's asking us to request access.
Sorry?
It's asking us to request access to the folder. I wonder if there's a way to change the privacy settings on the folder.
Yes, just refresh. Thanks, Shifa, for letting me know. I've changed the settings.
Okay.
Can you confirm now? Or Shahid, there is a question. Kindly perform RMSE also.
Okay, I will do that. I'll do that. Okay, though it is in the last, but I'll do early. If someone interested, I'll do early because sometimes we do not have time. Okay, is working, right?
Sorry.
Okay.
Yes.
Yeah, Shifa says it's working. Okay. So now now I'm doing for you the split half, right? Say for example, you have to understand the background. For example, this is how many items here? We have 8 items, right? Normally Cronbach alpha should be done with 2 to 5 items. So more items, then you cannot overload your box with so many, though you can do it, but it doesn't sound well. So your institution has produced this 10 items OSCE as one score. You cannot do Cronbach alpha, you cannot do anything. So ask the exam unit, send me the individual station score. Now they have sent the individual. Now what I'm doing, I will not run it for the Cronbach alpha, I will run it for the split half. So analyze, right? Go to the scale, reliability, and then go to drop down here, model. And in the model, I drop down, I pick split half. Okay. Now, when I do the split half, I can straight away take the item, this one, item 1 to item 8. 8 items are there. I can bring it to the item box. Okay. Now, from here is not alpha, is a split half. Now go to the statistics, and here we are interested in nothing but in scale. So I click check out scale, and then I go continue, right? And I press OK, click OK, and I get this. So with the split half, you see the interpretation, right? With the split half, if you look at the valid 30, all items are valid, no missing. Here is divided into 2 parts, part 1, part 2. And if you look at A and B, it's telling you what is part 1. Part 1 is OSCE 1, OSCE 2, 3, and 4. So what they have done, they have just divided 8, top 4 and bottom 4, right? But part 1 is the Cronbach alpha, part 1 is 0.355 and part 2 is 0.193. This might happen. Why? We might have set question in a way where the easier question are put in the earlier part, and the OSCE station first 4 may be easier, or OBA may be easier than the rest, right? So this is here. But what is important? Important is the correlation between the 2 parts or the forms. It is 0.167. But this 0.167, mind you, is the half the length of the test, because we have splitted it into 2 halves. So it half the test 1.67, right? So this is compensated to full length by the Spearman-Brown coefficient, which is 0.285. So you will not take it as 0.167. So your correlation, your reliability coefficient is going to be 0.285, Spearman-Brown. But what happens if we do it, because here we are doing all everything divided into 2, right? But ideally it should be it should be odd and even, right? Because odd and even mean that those questions which are difficult and easy will mix up. Okay, so I'm doing analyze, I'm doing back, scale, reliability, right? And these are the numbers, right? Now I want to make it odd one group and even number another group. How can we do it? Very easy, right? As I said, is number 3, click here, bring it to number 2. Number 5, click here, drag it up after number 3. Number 7, click here, drag it after 7, right? So what is it? 1, 3, 5, 7 is one group, which is odd, right? Previously was even, right? So all these two groups, 1, 2, 3, 4, and here we have 1, 3, 5, 7 odd numbers, right? And then another is 2, 4, 6, and 8. Now we run again. Okay, we have changed the order, statistics, scale, item, right? We are interested in scale only, so continue, and then click OK, and we get what we get here. Now you see what happened. Here's a part 1, though is dropped down. Part 2 is here, but when you look at the correlation, this is what we are interested in between the two parts. Previously was 0.167 is not 0.385, and when this is half, right? This is half the length. Look at the full length, which is compensated by a Spearman-Brown coefficient, is 0.555, which is a quite good correlation. Okay, so this is a split half. Okay, done. So we have done this. So I will close this down, right? So that, yeah, I want to proceed with yes. I don't want. Okay. So to close that, save the content. No. Okay. This one also, because if I open too many files, do you want to proceed? Yes. Right. Now moving on to the ICC, I will do later because someone has really asked for the root mean square error. So before the time lapses, we will do the root mean square error. Root mean square error, the package is not provided in SPSS, so we are going to use what we call it, the Excel. In Excel, the provision is there to do the root mean square error. Root mean square error is another way to know the reliability of the OSCE, and it is much more effective and practical, and in reality is much more statistically sound, right? So what happens now in OSCE, because I saw the survey.
Prof.
Yes.
As I understand, you do split half for OSCE station reliability. Is this right?
No, that was split half. You can do it with any, even you can do it with OSCE, you can do it with OBA, you can do it, but in OSCE usually we have a small number, right? Usually it is done with bigger numbers. So OBA, SEQ, those modified essay question and all, multiple true false, split half is done more for that. Is that okay?
Okay.
Or in OSCE you will either do Cronbach alpha, or as I said, Cronbach alpha, 10 station OSCE, your Cronbach alpha will be very poor. Literature says, in literature, people have not achieved 0.4 to 0.7, whereas 0.7 is acceptable. So mostly people will live, and you do it yourself also in your setting, you will find OSCE Cronbach alpha is very poor. So you don't get frustrated, because they are, each station are different, of different dimension. They are not unidimensional. And then Cronbach alpha, the assumption is the item will be consistent. If they are not consistent, then you will have a poor. So root mean square error. How do we do it, right? So first thing, you have to pay your attention to it now. It's little difficult, but not that difficult. Okay, I'll make it easy for you. First of all, when you develop the data sheet, remember I'm not spending time on how do you do it. So the OSCE, you do it with the borderline. This is the assumption is that you're doing the borderline regression method, right? So you have a checklist score, which the examiner will follow simply as the student performs. They will check out performance, and this will be a checklist score versus a global rating, which is the overall performance. Any institution can use any number, like at a scale 1 to 3. In IMU, we use 1 to 5. 1 is fail, 2 is borderline, 3 is pass, 4 is good, and 5 is excellent. So after the checklist score marking, as an examiner, throughout, I must have been following them, I must have been observing them for their overall competence, their confidence, they are handling the SP, right? They are taking the questions from the SP, their body language, their sitting arrangements, they're using the instruments and all. So overall, though in sometime, OSCE, what happens? We say greeting, get 1 number, introducing, get another 1 number, and then thanking the patient gets another number. So if out of 10, 5 is the passing marks, 3 you already gave him by doing all these 3 exercises, right? So this is not the true test of competency. So what we do, so you have to be realistic with your checklist. So overall, global rating has been established in literature is slightly superior than the checklist score, because checklist score sometimes is done in a way where students get a benefit of it. And you must have seen students pass the exam, most of the center where you observe the standard setting strategy, which is about grading the student. If a student practices compensatory standard setting strategy, meaning the written test questions combined with the OSCE, then they will get the grade. What happens? The student pass, mostly pass. Their performance is not good in long case, short case, or in written, but they pass because of the OSCE. So OSCE sometimes is easy to pass because of the way we develop the checklist score. So that's another discussion forum, right? So now looking at the group, so you have to put the first column on the left should be your global rating score. If you do it checklist on the left side and group and right, then this is not going to work, right? So this is first condition. So a worksheet. Then you develop the model. What is the model? We need equation. The equation which is provided with the number. So there are 2 ways of getting the equation. I will follow the easier way for you first. So the equation is that you go to the insert, right? You click insert here. Okay. Okay, insert. Then we get this scatter plot here, right? Then you highlight these 2, not the label. GRS and CLS I'm not. That's just the highlight the global rating and the checklist score. And then I go to my scatter plot, right? Then I click the scatter plot, and there I get this thing, right? Here I get this one. So I move it here. Now I want the equation. To get the equation, this is how the global rating against the hour is 2. Our global rating borderline is 2, so we are marking at 2. So this is how the score is distributed. The small number, so it gets like that. Otherwise, it will be more like a graphic way. Okay. Anyway, so now you go to the add chart. So from here, drop down and go to the trend line, right? In the trend line, move down to the more trend option, right? And in there, you see the line of intercept is not reaching the y-axis. So I do not know the slope line. What is the line of intercept? So simply here, you can increase this number. So I make it, say, for example, 2, right? And then I press this one, and suddenly I get this, right? So the slope line now touches the y-axis, which is the line of intercept. Now I'm interested, more than that, I'm interested in these 2. Display the equation and display the R square. Okay. Having done that, I close this and I will get that. Now I got this. This is my equation, right? Now, if you all remember the predicted score, we have to calculate the predicted score of all the students, which is called model. Okay. So say, for example, whatever score the students have, it will be, if you put it in a graphic way, it will, all the data points will appear along the x-axis and y-axis. Then what you have to do is that from that axis, x and y, then you have to develop you have to draw a regression line. So regression line, what will it do compared to the mean line? Regression line will minimize the dispersion of those data points. So we are looking at that this regression line is in a model is working well or not, meaning that the global rating score against the checklist score is working well or not. This is about the model. So how you calculate? So you have to, I'll put little bit this little, I want to emphasize because somebody is interested in this test. So go to home, right? And then increase the font size, make it 12, so more readable, okay? Now there you are, okay. Now the model, how do you develop the model? You remember, here is 17.47x, ax plus b, right? So this is the equation and this is the number. X is your global rating of individual students, okay? So what we do is we put here equal sign, okay? After the equal sign, you put the line of slope, which is 17.47, 17.47, right? Times x. X is the global rating score. So I press shift and 8, right? On the this key. Okay, so the 8, the asterisk will appear, which means multiplication in terms of Excel. Okay, now what is X? For this student, X is the global rating. I click here. So he get the 3 right here. Then I add plus here, right? And I add the line of intercept, which is here, which is line of intercept is here and is indicated in equation 23.35. So I add 23.35, right? And then I enter. This is the predicted value of this student. Though we have given him 80, right? Checklist says 80, but the predicted score says that he is worth 75.76. Okay, anyway. So now autofill, just drag it down until there, right? This is autofill, okay? This has been autofill. We don't have to do individually for each one. Now the residuals. What is the residual? The observed score, which is the checklist score minus the predicted score. So what we do here, this is residual. This is going to be the residual, the error, right? So we equal here, then we click the observed score, which is 80, right? Minus the predicted score, which is the model we have created here, and then press enter. 4.24. This is the residual, right? So this is I'm going step by step. First is to develop the model. Second is to do the calculate the residual, right? Which is model the observed score, the checklist score, or the observed score minus model. Then autofill. Okay, I do the autofill here, 30, right? Here. Now do the residual square. Residual square, equal sign again, right? Then click this, right? And residual square. So all the residual we have to square. So shift, press 6. 6 here, you get this. And then 2. This will, oh, sorry, I pressed something wrong here. Okay. So
2 need to
okay.
be
Yeah,
numeric,
yeah.
right?
Yeah, numeric. No, I press shift actually, so that's why. Okay, 2, right? And then press enter. This is your residual square. Now, residual square also autofill, but the last column you don't need to autofill because it will be 1 score. Root mean square in place as a reliability coefficient. So what do you do here? Here the formula is equal, right? Then there will be square root. So you type SQ and pick up square root from here, right? Within bracket, then you actually this you have to bracket also, right? Better. I mean parentheses, right? Then go to this, right? And put sum. Okay, SU sum. I click here. So the sum actually is it in the within the parentheses? I think is not. So okay, now it is within the parentheses, right? And then divide by number of the participants. How many? These are 30. So we divide it by 30 and press enter. There's something wrong here. We have to redo it. Okay. In Excel is very sensitive. So again, equal, right? After the equal, parenthesis, square root. There you are, a square root. Then sum. You click sum here. Then can you bear me out whether I'm parenthesis is doing well or not? Okay. Here, yeah. Okay. Then divide by 30. Again, something is going wrong. I use the other one.
Just now, it automatically selects the parenthesis. You don't need to move anything.
Okay. So this
Do it
one.
Again.
Okay. No, I'm using another additional parenthesis actually. So that's why. Okay. So this which I need to. Okay. Square root. Okay. Now I'm not using additional parenthesis. Sum here, right? Divided by 30. I have to, because this 30 is going out of parentheses. Okay. I got it. That is what will happen with this Excel. So anyway, this is the, you try it at your end, you will probably what this is parenthesis, square root.
Dr. Nazar would like to comment.
Okay, Ken. Okay.
Hello?
Yes, we can hear you.
Yes. You do square root and then sum. You should sum something. I think between the bracket of sum, there should be a range of data to work. Otherwise, it will not work.
Yeah, this is what I'm taking the data, the square root, right? Equal square root. Then I open a parenthesis here, right? And then I do, yeah, I do. Then I take all the data here, right? This data, right?
No, you should write sum and then you should select the range.
Write what?
Sum.
No,
write sum.
Yeah, this I have written some. Did I written some?
No.
Yeah. Okay. No, right. Previously I have been writing a square root, right? Then sum. Okay. There is sum, right?
Then select the range.
That I'm selecting here. All this, right? And then dividing it by number 30.
And close the parenthesis.
Close the parenthesis.
You need to add another parenthesis at the end.
Before the divide.
Before
divide.
Before divide.
Yes, before over. Yes.
You mean here?
Close. Yes.
No, here. Okay.
Yes.
Okay.
Okay.
And
then,
another parenthesis also, or no need? No need. I think there is another parenthesis also, because we have to close the overall.
Yes.
Yeah.
Okay.
But this is But this is a bit high. This is a bit high, right? This is a bit high, and I think this is the procedure, but it should be less than. But it depends how the global rating is predicting the checklist score. It depends, right? So this number can be different, but you apply this, it should be as minimum as possible. Literature haven't, like Cronbach alpha and all, there is no specific number given for this, right? But it should be as less as possible. It should be around 1 or less than 1. So here, this is how you get, but if I do few time, I think what we are doing is using our parentheses and all probably is not very nicely done. So anyway, this is how you do it. This is your root mean square error. Okay, got it? So anybody has a question on this first? And I'm repeating, there's no cutoff point or a specific number in literature. It is said only 6 or 7 papers have been published in literature where they have shown as minimum as possible. In my case also, I have done it in my setup. It was a 0.8 or something, right? which should be as less as 1, towards 1. So as less as 1 is quite acceptable. Okay. So, but it depends how the, for example, global rating, usually junior examiner, what they do is they keep themselves very close to the checklist score. So normally we tell the examiner, don't total your checklist score. Once you total, for example, you get somebody is getting 80%, then your global rating will be little biased. So don't total your checklist score. Before you total, or let it not be total, examination unit will do it for you. Without looking at the checklist score, give him your global rating. So the junior examiner, usually they keep themselves very close to the checklist score. In that process, the global rating prediction for the checklist score may not be accurate. And this root mean square actually determines the accuracy of regression equation, taking into account the global rating and the checklist score. This is how it is done. The other way of getting this score would be the ANOVA method. Okay, so you can do it in ANOVA method if you all have in regression method actually. So you have to go to the data, right, and data on the right side you see data analysis. It is hiding under this data analysis. You have to download this package. If not, you go to file and option is there, so you can download. So in data analysis, you go and click here, right, and go to your regression. This is regression. Okay, okay. Then you can add your this is y-axis. So y-axis means checklist score first. Okay, so all the checklist score until 30, right? Then you have to clean this previous data. Okay, I should have cleaned it earlier. I should have cleaned this also. Okay, now you go to your input for the x-axis. X-axis is global rating, right? This is x-axis. So you do this all the 30, right? And then you click here, right? And then click on any one cell, right? And then go click OK. Okay, you get this. In here, if you look at your, this X variable is 17.47 is the same here, is the line of slope. And your intercept is 23.35, 23.35 is here. So you can use one of these methods. I go by either go by graphic scatter plot, or you go by using the data analysis, which you can download. If your Excel doesn't have it, downloading is file option, and you can add in, right? Add in the data analysis, and data analysis, you just click and you will have all these options which you have in SPSS, correlation, regression, ANOVA and all you can do with this. So, okay. So you will get the same thing here. You can use this number from here. But what in addition you get? In addition, what I'm going to do an exercise for you is the standard error of estimate. You are getting it here without doing any efforts, no calculation, nothing. But 7.26 is the, what it is? It is the standard error of estimate, or in so many words, standard error of measurement. This is error 7.2, right? At the same time, you get the R square, which is 0.58, which we get here also, right? In this scatter plot, meaning that 0.58, 58% of the global rating is responsible for a change in or impact on the checklist score. It should be more than 60%. Okay, here we have a 58%. So 60% above is supposed to be good R square. R square, again, how do we achieve it? The basic, this has advanced course again. We will do that in advanced course. So R square actually will tell you about how much global rating has got an impact on the checklist score in regression equation. So this is how you do it. So I will close this also.
Some clarification. Do
Yeah,
you sum RMSE for all stations to obtain
okay,
RMS?
very good. I think you see, that's why I encourage questions. So you do this is for one station. Okay, so you do, if supposing you have 10 stations, you do the root mean square error of the 10 and do an average of that. So supposing I have 10 stations, 10 root mean square error, and total divided by 10 will be my average of the root mean square error. Thank you for asking this question.
Yeah, and
Okay.
I think you have already answered, but just to clarify, what is the best value for RMSE?
Yeah, I told, I answered already. Literature
Okay.
has not suggested, is not established, but they should, it says that it should be as less as possible. So more closer to 1 or less, right? My opinion, less than 1 is better, right? Here we can see there was some error in our doing it. It is not 0.6, I have done it. It was 0.8. So there's some error in our doing it, but I don't have time to redo it for the correction. But when you do the same data you have, you do it, you will find it the right one, right? So, but this is how it is done. So the literature, no specific value is attributed to like Cronbach alpha and split half and correlation, but it should be as less as possible. Okay, and less mean more towards 1 or less. Okay. Now I'm closing. If you have no more question, then I go to the next ICC, right? I don't save. I don't want it to be saved, right? So now next I'm going to do with you the ICC, right? Let me open this data. ICC is the other reliability test, which is inter-rater reliability. Supposing in an exam, you have oral, you have short case or long case, you have more than 1 rater, right? Then you want to see whether this has been effectively done or not. You use this ICC, intra-class correlation. Now, how do you do it? I will do it for you when you can follow. Take a little time in opening. Okay. Okay, now we are going to intra-class correlation, which is the other method of knowing the reliability, which is about the, so this exam, there are 10 students, 15 students are taking this exam, and we have 3 raters for this exam, say oral, viva, or whatever, right? Short case or long case. So 10, and they have their marking. So now we want to see that how much agreement between these rater is. If there is no agreement, it may not be the fault of the students, right? We have to look into it. Why one examiner is giving 7 and another is giving 3? There's quite discrepancy. This discrepancy should have, every institution determines for undergraduate in IMU, we have 20% discrepancy allowed. Okay, so if this is 3, this is 7, this is more than 20%. So this will not be considered reliable. But we have to have other evidences to it. So you go to analyze, right? Then go to scale, go to your reliability, and then go to alpha, right? So bring all the 3 scores, 3 raters score, right, into the test box item box, right? And then alpha, right? So you have to put alpha because ICC is embedded in it. Okay, so go to statistics. Okay, now we are interested in item, in scale, in correlation, in mean, and finally intra-class correlation. Now the moment I click this, check it off on, right, I check out this, suddenly model became available. Before that it was not. If I disclose, it is not there. When I check out this, the model appear. In model, in drop down, you will find 3 options: one-way random, two-way random, and two-way mix. One-way random mean either the students or examiners are picked up randomly. They are random, right? Two-way randoms meaning both are random. So students change, examiner change. You are using different examiner for different student. Then most commonly we use two-way mixed. In two-way mixed, the examiners are fixed. Okay, so we are using that. Next, so we are using two-way weights, which is mostly, you should always use that because in our case, examiners are fixed. Okay, now go to consistency. Drop down. We have consistency and absolute agreement. We are interested in absolute agreement. We are not interested in how consistent their result is, right? We are interested, for example, what does it mean? For example, one examiner has given 3 marks, another is given 7. To the next student, 2 marks and 6, the other examiner give. And again 3 and 7. So one is consistently giving low marks, another is consistently. So this is dog and half. You know, you may have a lenient examiner versus a stringent examiner. So though they are consistent, they are scoring, but there is a difference of agreement between them. So this is not the student's fault. So what we do is we press absolute agreement. Okay, then we continue, right? And then we press OK. Now what we get is the table output here. You look at the missing data and all. Cronbach alpha is 0.842, which is very good. In this case, 3 raters are having a good agreement, right? Then we put the item statistic, which is mean and standard deviation is also very important. I'll check with you the table, which is important. Mean is important. You look at this, one examiner, overall mean is, examiner 1 is lowest. He is little stringy compared to the examiner 3, rater 3, 6.93. So he is towards little high and he is towards low, right? So this is one. Item, inter-item correlation. If you look at item, rater 1 is very well correlating with rater 2, also well correlating with rater 3. And so the 2 and 3 are also well correlating, but they are slightly on the lower side, should be 7.7. Why we can't actually achieve 0.7 all the time is not so 0.6 to me is also, they are near 7. So okay, but what is important is here, the last table. You come to the intra-class correlation and then you see single measure. This is a single measure, forget it. Average measure, we are focusing on this average measure. So this is 0.78, which is more than 0.7. So intra-class correlation, meaning the agreement between the 3 examiners is quite good. See, so the lower bound, though it is not achieving 0.7, and upper bound is quite high on coefficient, but the lower bound versus high, this is confidence level, right? So this is lower bound is this, but it is still okay as long as the intra-class correlation is more than 0.7. So this is a good agreement, and on top we look at the significance level is less than 0.05. If we keep our type 1 error, which is 0.05 or 95% confidence interval, then we are achieving it well. It is quite significant with 0.7. So this is intra-class correlation or the inter-rater correlation. So that's done, right? So I close this.
Sorry.
Yeah.
There's a question. If you have one station of ski run in 3 places, but by different examiners, can we do this analysis?
Yeah, that's right. That's what you should do. You should do, right? Because I recently received a request from the examination unit coordinator, and what happened is in our module 10 exam, the practice is we have they submit the case write-up. On a case write-up they submit online. That 3 examiner will go through that and then they interview the student, right? So the long time practice has been that there are 3 students, 3 examiners. 2 are from the discipline. For example, if it is a surgery case write-up, 2 surgeon and 1 from other discipline, right? So this was kept keeping with somebody who initiated this, that there should be a neutral kind of umpire among the 3 or the supervisor. So they kept 3. But over the time, it was felt that this is quite cumbersome, and having 3 examiners, sometimes we do not have enough faculty and all. And other logistic reasons, they reduce it to 2, right? Now, the examination unit has said this time only there are 2 examiners. 3rd one has been removed. Now the Senate and the academic office want the examiner unit, examination coordinator to submit a report that this has worked well, that removing 1 examiner actually has not affected the validity or reliability issue. So the data is with me. I haven't done yet. I have received just yesterday. So I will be doing that and then sharing with the examination, with the exam coordinator, and then he or she will be sharing it with the academic office and the Senate. So this is how you go do it. Any other question, Hasnan?
Yes, Prof.
Yeah.
Inter-rater score applied to the global score only?
No, this inter-rater is always global, is a subjective, right? But subjective, sometime it may not be global in the sense that you do not have the overall assessment, but you have sometimes you ask question and you have an answer to it, right answer, right? So you look at the right answer. So not global in the sense that you are subjectively assessing the student's overall performance. Sometimes these, for example, you are doing oral. So in oral, you have a question, you have a model answer, right? So this is not global rating. This is to reduce the subjectivity, right? So a question is asked, model answer is there, and then you judge your student based how much he is close to the model answer. But if it is not like this, for example, you are going OSCE, they have a checklist score on top. You look at his overall performance, like patient, doctor, or the candidate relation, repo, his caring, right, care for the patient, his confidence in taking the SP or the patient. So those global rating in the sense overall clinical competency, then is global rating. But if you have a model answer and you're following through that, then this is not global rating actually, though it is subjective to mark. That's why the difference may be there between the two, but it is based on a model answer often. Okay, I hope I have answered.
Sure, Prof. Sure.
Okay, can I move to the last one?
Yes.
Okay, so the last one is I close this. No. Okay, so the last one is about hands-on, is about root management we have done. This is the fictitious data for Excel standard error of measurement, standard error of estimate. I click open this Excel sheet and we do this. Okay. If you look at here, so we have a standard error of measurement, right? And for a standard error of measurement, we should remember the formula. What is the formula? A standard deviation, square root 1 minus r. So you have to calculate the standard deviation first and the reliability. Okay. So what we do is very quickly we'll run this. So what require formula is, first is what we need, standard deviation. We need the reliability, meaning the alpha, right? And then we apply the formula, which is the formula is standard error of measurement there, right? The formula is SD asterisk square root 1 minus the reliability, better small r, right? Reliability. So this is what we have to do. So this is the formula. So we have to calculate the standard deviation. So very quickly, so we are determining the standard error of measurement of this data, which is SEQ, 5 SEQ taken by these many candidates. Okay. So what we do is a standard deviation, right? So we equal STD, which is a sample. So this is a sample. So we STD sample, not population, right? And then we take all this into account until 5. Okay. We get enter. We get 8.4 is the standard deviation, right? Now we have to calculate the alpha. As I said, to calculate the alpha, we have to use the ANOVA in Excel, right? Because we are doing it in Excel. So you go to the data there. Okay, data analysis. pick up ANOVA. This is regression. So go up, there is ANOVA without two-factor replication. Click this, right? And click OK. Now you get this, okay? So you get this. So you go and in ANOVA, then you get the input range. So you, and I clean the sheet first, okay? Okay, so input range is all this. So I take all the five scores, score. Alpha is 95% confidence interval, 0.05, okay. The output here, I click here, right? I want to keep it here on the same sheet. If I put new sheet, it'll go to the next sheet. So here, and then I just click this cell, right? And then okay. Then I get this. Now down there, I have got this MS rows and MS error. And I said the formula is, so if I do it here for your convenience, see the formula of will be for reliability for alpha. Alpha, the formula is that you have 1 minus, let me check, yes, for standard error of measurement. Yeah, 1 minus MS error versus MS rows. So I put equal sign, right? 1 minus parenthesis open. Then I click the error, MS error, which is this, right? Divided by MS rows, which is this, okay? Parenthesis close, and when, so reliability is 0.562. So going back, right? Going back, alpha is 0.562, 0.562, right? So standard error of this will be, now we calculate, plug in this, right? So a standard error of measurement here, we plugged in, or you can do it here in the same line. So standard equal, right? Standard deviation is this, right? Then asterisk, shift 8, and then parenthesis open, 1 minus what is reliability is this, parenthesis close, and then do this. So the standard error of measurement determined here for this data that we have is 3.70, okay? So now we take the average of this. Supposing the average of the whole thing you take, or what the student score, for example. So the one student score, for example, SAQ 5 is 70, right? We have to do the totals, right? Actually. Why not we do this? So we do a total of this score, but I don't have left this space. I do here the total of this score, right? The total of all this you do, you have to determine a mean also to apply the standard error to the conference. So you have this score there, right? Enter. No, I didn't put the.
You need to put sum first.
Sum, yeah, that's right. Okay, so sum, and then drag all this. Okay. Having done this, 300. Now the autofill until the number that I have, how many? I see until here, okay. So this is the score, then we take an average of this, right? So an average of this score will be equal average, right, here, and then I do all this, enter, 317. Okay, so the average is 317. Just look, I'm giving you the overall, but you can calculate it for individual. So if the mean is 317, then this is not the true mean or the true score of a student, right? So what would be the true score? You go with confidence interval, right? CI, which we are keeping 95%. Then you have to have a Z-score, right? A Z-score here. A Z-score is important to calculate 95%. So this standard error, which is, what is the standard error we determined? Is 3.7, right? This has to be multiplied with Z-score if you want to have a confidence interval 95%. If confidence interval is a standard deviation, one standard deviation, then it is 68%. So do we want to be confident that 68% result that we are producing is the right score, or we want it to, obviously the most practice is 95% confidence interval. So at 95% confidence interval, we have to calculate the standard error of measurement. Okay, so for this, actually what we do is Z score we know is 1.96 at 95%, 1.96, right? We all know, but you can calculate this also with 0.05. So this has to be multiplied, asterisk there, by this number, which is this. Okay. Oh, I didn't put equal sign, right? Okay. You have to put this small error in Excel will not be accepted. Okay. This, and then click here and then enter. So actually, if we want to be 95% sure that this score of mean 317 is the true score, then this error is over there. So we have to calculate the lower bound, right, and the upper bound. Lower bound and the upper bound. Okay, the lower bound will be equal, right? 3, this score, which is a mean. I'm taking a mean, but you can take for individual student, right? For convenience, I'm using minus this score. Okay, enter. 310, and then here upper bound equal, right? The standard error of measurement in though it was 3.7, but at 95% confidence interval, we'll taking it to 7.25. This one, then minus this, plus, sorry, minus we have done the upper bound plus this score. So the true score of here is a range of 310.40 to 324, which is not a bad, but standard error of measurement should not be, ideally should be less than 3. People encourage it is less than 2. But here, when we multiply it with the Z score to have a 95% assurance, then the true score of this exam in terms of mean is between 310 range. Say similarly, you can calculate it for individual students. Okay. Now the question is, somebody may ask, what do you do with this standard error of measurement? You have calculated, but then you have to decide if it is standard error of measurement is too high, then you have to really think of whether a result should be announced with this standard error of measurement or not, or there should be some adjustment. So adjustment made is according to the institution's policy, right? But this range should not be very big range. So anybody who falls beyond this range, for example, is less than this range, then he shouldn't be considered as pass. So there is various way of adjusting the score. So this is the practical aspects of the hands-on. I'm happy I have done all the hands-on that I have kept for this. Any question for this here? So this is standard error of measurement. A standard error of estimate, you saw when we did regression, it automatically appeared in a table. So you can get it from there. But if you want to actually achieve it, then you can have also. So for example, I was just telling you that Z square you can calculate is manually also. So what was our probability? The alpha we kept was 95%. So we allow one, type 1 error is 0.05, right? So if you really want to calculate the z-score, so your z-score can be calculated with the formula, which is in statistics. You have to press equal, then you type norm, N-O-R-M, norm, and then see with the norm, this one, norm SINV, right? And then there is one argument only, and this argument is you have to have within parentheses 1 minus, right? What is the argument? Argument is we are keeping it 95%. So click here, divided by 2, right? Divided by 2 by 1 tail, and then enter. You see, you get 1 point almost. If you reduce it, it will become go to home, because there are too many decimals here. So if I reduce it, it will become 1.96. Now 1.96. So you can calculate, if you forget your z-score, you can calculate it using this formula. Type equal norm dot s dot inv, then make your argument, which is 1 minus alpha divided by 2, you get the z-score as well. Okay, so I'm done here with all the hands-on. So standard error of measurement and standard error of estimate, all along I have talked, but if you want to be exclusively talked on that, I have a few slides, but I leave it to the organizers of this workshop. Zoom, are we beyond time, or we are still time? So practically I'm done. If questions, yes, I welcome.
Thanks, Prof. I think it was really a great session, and I think we are almost over time.
Okay.
So we may take some questions. If you have any questions, sure, audience can type in. I noticed, I think when you were doing hands-on, people were more concerned about recording of the session and getting the cert. So just to clarify and remind, this is our norm for all our webinars and workshops. We are recording all these sessions, and you will be getting access. And once you have completely attended the session, you will be shared the link where you could download the cert for each session.
Hassan, do you allow me just 2 minutes? Is it okay?
For
just 2 minutes, just to give a little idea on regression, because many, you see, just 2 minutes. So this data, we get this data along y-axis and x-axis, right? Global rating, checklist score. These are the data points, the score, right? So we draw a mean. This I'm telling you, this will be the advanced course, but how it works, regression line. So mean, this data is scattered mean. The next we want is to draw the distance from the mean, right? All the data points. Next, we do a regression line. So this is regression line. Actually, when we draw the regression line, this will squeeze towards the regression line to minimize the distance. So here we have to calculate from the actual distance from the mean is called SST. So, sum of these total. Then another, if you look at, this is the actual data, this is the regression when it regressed. So and this is the mean. So from actual mean is SST. The next is from the predicted score, which is regression at the regression line. From the mean is SSR, right? And then another you get is from the actual score from the predicted score. So what is R square? So just to tell you, because I'm not going in detail, R square is a ratio of SSR, which is predicted score minus mean, versus SST, actual score from the mean. So you take a ratio of this is your R square, which is actually giving you the accuracy that how much global rating is really influencing or having an impact on the checklist score. So that's all. That was the gist of this talk. So I just touched on those important slides. Okay.
Professor
Thanks,
Shahid,
Prof.
thank you very much. Professor Mulazim Hussain Bukhari speaking. Thank you very much. Have a great, it was a really great session.
Thank you very much, Bukhari.
Sure. I think it was one of the session I would just comment and pass on to Prof. Shabi. It was one of the session where we started with like the participants all were there till end. So that's, I think, great credit goes to the participants who were here. And I would personally thanks to Prof. Shahid. At this age, you have great energy and, still remember all these minute things. So may Allah bless you and have increase in your knowledge. So hand
Thank you
over
so
to
much.
Chabi to conclude.
I'm humbled with your kind words, Hasnan. Thank you so much.
So Shahid, it's Shavi here. I just tell the audience, and when Shahid and I used to operate in Malaysia with head and neck cancer, very advanced tumors, maxillofacial region, larynx, thyroid, 8 hours, 10 hours, including reconstruction and flaps. When I get exhausted, I'll go sit in a corner. Shahid will still continue. Same spirit continues. Well done, Shahid. You are an asset to all your friends. God bless you all.
Thank you, sir.
And thank you so much. We are impressed with this presentation and more to come in the future.
I'm
Over
really
to Shifa.
humbled, yes, sir. I'm
Well,
really
you
humbled, Prof. Zadi, but one word for Prof. Zadi. He is the motivator for all of us. Look, what he is actually, if I get frustrated or something exhausted, he will motivate me. And so I always get that motivation from him. He's really inspiring person for me.
Thank you so much. A wonderful team. So over to Shifa to conclude, please, and announce for the next program. Thank you.
Thank you so much. I just wanted to also thank everybody for joining us. And Professor Shahid, as always, it was amazing to get to witness you in action. So thank you so much for that.
Thank you, Shifa.
Thank you. I just also like to mention to everyone, hopefully in a short while, you'll get a link to the certificates in your inboxes on the emails that you registered for. And just an announcement for our next event on October 10th at the same time, 11 o'clock a.m. GMT, we'll have a session with Professor Lambert on modern assessment in medical education. So we look forward to seeing you all then. Thank you so much.
Goodbye, everyone, and thank you for your participation. And thanks the organizing team. Thank you very much.